Hi everyone. Today we'll take a closer look at IC burn-in testing and answer some common questions about one of its key components, the burn-in socket. First, what is burn-in testing? After an IC is packaged, it may undergo burn-in or reliability testing. Burn-in testing simulates real-world operating conditions, such as high voltage, high temperature, and long operating hours, to identify and screen out unstable chips and potential early failures before they reach the market. Reliability testing, on the other hand, evaluates how the device performs over its expected lifetime, helping to reduce the risk of field failures in real-world applications. So, how does the workflow actually work? In a typical setup, the sockets are first mounted onto a burn-in board. The DUTs are then loaded, and key parameters such as voltage, current, and temperature are set for the batch. The entire assembly is placed into a burn-in oven, where it runs continuously under a controlled environment. Throughout the process, electrical parameters are monitored in real time. Once the test cycle is complete, the ICs are removed for data analysis. However, if an ITC socket is used, it connects directly to an independent heating system rather than relying on the oven. This allows for individual temperature control of each IC, which is ideal for applications where thermal precision is a priority. The next question we often get is, what are the requirements for a reliable burn-in socket? There are 4 key factors to consider. First, burn-in socket needs strong thermal stability to ensure stable contact between the probe and the IC during high and low temperature cycling. At the same time, the materials must be resistant to oxidation and corrosion to prevent signal loss in harsh, high-temperature environments. Second, the probes need to maintain low electrical resistance, and the spring structure must go through long-term compression testing to ensure stable contact throughout the test process. Third, the socket must provide excellent insulation performance, along with effective thermal paths to prevent localized overheating of the chip. And finally, it has to maintain uniform contact pressure, ensuring reliable performance during long-duration, high-temperature, and high-current testing. If you have any questions about your specific testing setup, feel free to reach out anytime.